Swayam Prabha. Digital India. Educated India.
Analysis and design, and so we have to build structures which are safe, useful, beautiful. This is what was told to us thousands of years back, but the question is, what is safety and how do you ensure safety, right? We have seen some photographs where we have seen structures, buildings, bridges that have fallen down, and that is not safety. So how do you ensure safety? And this is where two important tasks need to be done, need to be carried out by an engineer, particularly a structural engineer, which are analysis and design. And what is analysis? It is to understand how a structure is going to behave, right? And design is to understand and control that behavior. So that behavior should be acceptable behavior, and that is what you ensure through your what is called design, and we will see little more. Very quickly, just to give you an example, all of you have seen simple buildings being constructed. Wherever you have lived, grown up, you must have seen. So, and these are these nice buildings with columns and beams and slabs, what we saw just a couple of slides back. So, in that the analysis and the design often is done with only for the frames, that is the columns, the beams and so on and so forth. But suddenly when we construct, we put these infill walls, the walls that you see, the brick walls. So what it does to the structure is, it changes the structure and it changes its behavior. So what you expect while you analyze and design the structure is not what you get after the structure is constructed, and that is not acceptable. So this is what I call ABCD of engineering or ABCD of structural engineering is, you need to analyze to reflect, the purpose of analysis is to understand and reflect the behavior of the structure that you are going to construct, and behavior is going to depend on what you construct, right? So you are supposed to construct only what you have analyzed and you have designed for, and essentially through design you control the behavior of the structure so that the behavior is acceptable, right? This process is very important, and it's not a it's an iterative process that you have to undertake to ensure safety. In this process, when you talk about analysis and design, how do you do that? Obviously, we use principles of mechanics, and without going into the details of it, and there are a whole lot of courses that you are going to take to understand each one of these. So we have mechanics for gases, liquids and solids, and to a large extent in structural engineering we use solid mechanics and structural mechanics to understand, to undertake, do analysis and to control behavior through design. And in this, the fundamentals are, the three pillars are equilibrium of forces or stresses, compatibility of deformations of strains, and of course constitutive laws, which is how materials behave. And behavior is not just under for the given loads, the behavior under statics and dynamic conditions. What are these? So we saw the stress strain curve, any general material, you have that. So we can say that the deformations of the strains are small or they can be large, right? When we saw the stress strain curve of that steel, mild steel, we saw it was more or less linear up to a certain extent, and then it became non-linear. So it remains elastic up to a certain limit, or it can be inelastic. And similarly, statics is where you have a load applied on the structure in a nice way. For instance, if you look at this table is carrying the load of this monitor and the computer, and it's sitting there, right? It's not changing. But sometimes you have loads which vary with time, and that induces additional response in the structure which is time dependent, right? So those kind of situations are known as dynamic situations. For instance, you have a very slender chimney and you have a wind blowing past it. So you will suddenly see that the chimney is swaying a little bit, back and forth, back and forth. That is kind of a dynamic response. Similarly, you will see a lot of videos about buildings shaking during earthquakes, right? That's another example of a dynamic. So when you do analysis and design, you have to There are many considerations, and these are the considerations that you will have to learn and understand how to use them, and only then you will be able to understand and capture how structures are going to behave, and that is part of your curriculum here, right? So, you are going to learn that. Coming to design, I mean there are a lot of ways design can be defined, but I find this particular thing extremely elaborate and very well written. It says it's a mixture of art and science, combining the experienced engineer's intuitive feeling for the behavior of a structure. Once again, the focus is on behavior of structure, with a sound knowledge of the principles of statics, dynamics, mechanics of materials, structural analysis, to produce safe economical structure which will serve its intended purpose. It's pretty elaborate. So, it talks about everything. But most surprisingly, it starts with this phrase, it's a mixture of art and science. And this is what I have been trying to impress upon you, that structural engineering is not just dry engineering, it's about arts, it's about creativity and so on. So, and then we will see. Experienced engineer's intuitive feeling. How do you become experienced engineer? How do you become experienced in something? Forget engineer. Only by practice. There is no shortcut to this, right? You want to be a good singer, you have to practice every morning. You want to be a good football player, you have to practice. So, you have to be a good engineer, you have to practice what you are being taught in every class, right? Please take it, there is no shortcut. So, you have to work hard, and you work sincerely, work diligently, and you will be successful in your life. But for that, you have to put in that effort. That is the first thing. And what is it that you are going to work for? To acquire sound knowledge. To acquire sound knowledge. Not just, okay, today this is taught, tomorrow in that subject that is taught and all. You have to take it beyond that, to acquire sound knowledge of principles of all this. And this is where you will see your whole curriculum. Today, if you go back and look into your curriculum, you will see all these items placed one after another, semester after semester, right? Such that by the end of your 4 years, you will not become an experienced engineer, but you will become an engineer. And then you will have to start practicing, and then slowly with your every project, every work that you do with years of experience put in, then you become that. But the other important words are safe economical structure, right? Safety is of paramount importance. You can't compromise on safety just for the sake of economy. That's another point I want to make, right? And the structure, of course, has to serve its intended purpose, and we always build a structure with a purpose. So, right, that is what we started our whole discussion about. So, you can see it's a simple, we had to build a bridge, they had to build a bridge over this river, and looking at the skyline of the city, they decided to build a structure, a bridge, which looks like a beautiful swan springing up from the river, right? It serves the purpose, but they add creativity to it. And that is what is possible in structural engineering. Science, you have to really understand what is going on inside, because if you don't, your structures will will surprise you in a very bad way. So, that is why they say structural design, right? This was a simple bridge. This was a simple bridge, and they kept on adding things over and above that, and then finally look at this beautiful structure that you have. So, that is why we said on the first day that the 5 tenets of structural engineering is not just safety, functionality and aesthetics, but also durability and economy, right? You can't, if I want to have a small shelter, I will not go and build a pyramid today with a small chamber in it, right? It has to be fast, it has to be durable, it has to be economic also, in addition to being safe and functionally correct. So, what are the things that a structural engineer has to do? Very quickly, I will not go through this. I am sure there are other occasions where you have been told about how civil engineering project goes, but the basic components, if I look at it, there is a design process, and that there's a administrative work including contracting and so on and so forth, and then the structure has to be constructed, or the system has to be constructed. So there's fabrication and construction, but there is one more important thing which we often miss is operation and maintenance. And maintenance, we are very bad at maintenance, trust me. We have to develop that culture also. We build a lot of good structures, and then we think once it is done, our job is over. Our job is not over. We have to continue to monitor it and do maintenance and operation. Very quickly, this whole design process actually has two major parts. One is the functional design, and this is where the whole feasibility study is done. Today you will hear a lot of these, feasibility study is an important aspect. You need to get so many clearances and so on and so forth, right? But one of the important part of that whole study is what kind of structure to build. I need to build a bridge. What kind of a bridge? Of what material? Of what system? I need to build a building. What is the kind of building? What structural system do I use? What material do I use? So all these decision making has to happen here. And they often say that if you do not put in enough thought, enough thinking into this process, then by the time you start executing the project, you will find that there are a lot of difficulties, right? So this is an important step, and this is where lot of players come into the picture. And as you can see, of course, you will have the owner, you will have the planner or the architect, you have other engineers, government bodies and so on and so forth, and you also have the structural engineer and the civil engineer, right? He or she has to start participating from this stage. It's not that, okay, let them all do everything, we will come at the end, because your input is also very, very critical in shaping the project in the first place. And then once that is done, then of course you will have the structural design, and in that also it's not a one-step process. It's an iterative process where you first do a preliminary design, you understand systems and so on and so forth, and then an important task that is to be done is cost comparison, because you have to do it economic way, right? And this is where again a structural engineer comes in and plays a very, very crucial role in doing this. And finally, once everything is kind of frozen, then you go and do your final analysis and then finally drawings and specifications. Right? That's not all. In the administrative work also, contracting, estimation and approving of fabrication drawings, actually supervising construction, everything is are important activities where a structural engineer has to play a role, including what we are talking about in terms of operation and maintenance and so on and so forth. So, a structural engineer takes part in each and every activity that you see in a whole project, a civil engineering project, right? And therefore, the responsibilities are very high for a structural engineer or a civil engineer, so to speak. First of all, you have to be technically competent, right? You have to know what you are doing. That this is true for any trade. Any trade you take, this is true. At the same time, you need to develop administrative skills also, because it's not just you. One man cannot build, make a whole project, such a big project. So you have to work with people and you have to manage people also, right? You have to understand economics of project, and you have to interact with people, and you have to understand social aspirations and so on and so forth, what the community wants from you, right? And so on and so on and so on and so on. There's a whole lot of responsibilities and duties that a structural engineer has to play in a successful completion of a project, right? So you have to develop, inculcate all these qualities in you if you want to be a successful engineer, if you want to be a successful structural engineer. And if you do that, if you manage to get all these qualities, it's needless to say that often you will find yourself being the team leader of such a big project, because a team leader is one who understands each one of these items and who has capabilities to handle each one of these items, right? So that's very important, and that's why I say that you have to be open to ideas and have new ideas. Don't be scared to try new things. We saw the mixing and matching of different systems, different materials, right? Somebody had to take that call someday that, okay, let's do it this way. People have done this, can we mix both of them together, right? That's creativity. Of course, sound technical knowledge and personal commitment. I like this cartoon and I show this cartoon, but just to say this is not the right, this does not reflect a good professional engineer, right? So this is not the right thing to do, and we will not do it. We will take responsibilities of our actions, we will be committed to our work, and we will do good work. That's the commitment that all of us will make towards ourselves. I'll stop here. I said this will be a very brief one. As usual, I've taken photographs and all from the internet, and I'm grateful to all the original contributors. If you want the links, I'll give you all the links.